Hey folks, welcome on this beautiful Wednesday afternoon. It is awesome outside. It's awesome inside if you're watching the TV set or your monitors or what have you. And welcome to Mathline. We are so glad to have you with us today. I'm Ernie Roberts. I am your host for this afternoon session of Mathline. You said, what are we going to do, Ernie? And where's my sidekick? Gary's gone. So it's me today, me and you guys, and we want to hear from you, all right? We would love to hear from you. Give us some calls, all right? The number is 844-686-2378. We've established there's a lot of people on spring, I was about to say spring break. Feels like spring out there, but it's really fall break. But you know what? We still have a lot of folks here in the area, the viewing area, all of our viewing areas that are watching the show right now. We want to hear from you, all right? 844-686-2378. Got to talk to some students from Seymour High School today and yesterday from Rockwood that watch Mathline, enjoy it. Hope they'll give us some calls, all right? A shout out to those folks with the Scholars Bowl teams that were here working out at our studio today. And it's always fun to meet up with some of our high school folks. But you know what? Right now, I want to hear from you guys, all right? So give us a call, 844-686-2378. And I understand we have a problem of the day that's kind of been baffling to a lot of people. So let's take a look at it. It says, solve for y. Check your solutions. And goodness sakes, notice it has an S in parentheses. I'm sure that means something important because there's more than one answer to this problem. We have y, and we're going to multiply it by a parenthesis, y minus 4. And we've got a plus 3, and we got, oh my goodness, we've got another y minus 4. And all set equal to negative 12. And some of you are going like, whoa, that's crazy. Well, let's see how crazy it is, or maybe how crazy it isn't. If we can just simplify this left-hand side. Even on Facebook, I had one says, experience confusion, on this. So let's see if we can work this out and get it to a form that we can work with. The whole point of how things look, we try to get it to something we know how to manage, all right? We try to get it to a point that we can say, yeah, that makes sense now. That works well. So my thing is, let's clean up our friendly parentheses, all right? And by the way, we will check our solutions. We need to on this, and I am going to go ahead and give you a hint. There are two. There are two of them this time, all right? And they're not that bad, all right? Just hang with me, hang with me. So let's go with it. Let's start distributive property time. Here we go, kicking right along. We get y squared minus a 4y. That's straightforward because that's what y times y. Don't put a 2y there, you'll be in trouble if you do. That is y squared minus 4y. Stop. Now pick up the 3. We're going to say 3, and we're going to run it through the next parenthesis. And that looks like, wow, 3y minus 12. And on the other side, I have a negative 12. That didn't change, did it? So, in looking at this, I see like terms. Again, like I said, folks, simplify it down. Get it to a point that's very manageable. So we have y squared minus y. I know some of you are saying, Ernie, it's still not manageable in my eyes, okay? So just hang with me. But it is starting to look a lot easier to deal with. Because at this point, we have a y squared. And remember, to solve a quadratic, especially one that looks like this, we need to get it set equal to 0 to make more clear. We can't factor, if we factor, we just right back to these parentheses, all right? We'd have a y minus 4 and a y plus 3, which doesn't help us. We're not ready to factor yet. We've got to set it equal to 0, then factor. And that's where this problem really works so well. So this is an Algebra 1 type situation. Those of you are wondering, what level are you working at today, Ernie? We're at Algebra 1 here, definitely. I would not expect you to see this in a pre-algebra setting. So we're going to add 12 here, and all of a sudden, things begin to look a little bit better. Why did I add 12? Because it gives me a 0, but it also gives me a 0 here. So my friends, look what just happened. We got a 0. We say goodbye to both of these. By the way, don't just leave nothing there. Put what represents nothing, which is a 0, right? You got it. So we got y squared minus y. All of a sudden, this is starting to look pretty reasonable. I mean, I can look and start thinking, what kind of numbers can I put in there? Well, how about it? I can put a 0 in there. 0 minus 0 gives me 0, so I already have one of my solutions. Are y'all good with that? So how are we going to find the other one? We're going to play, I say, well, we could throw numbers in there until the cows come home. Sure we could, and we could maybe get it quick, or we might hit all over the place and not get the right one. So let's work it really straightforward. We see a greatest common factor. I'm seeing a y coming out of here. So let's take the y out. And if we take a y out, we've got y, and we still have a minus something. Because what happens when we say we take a y out? We're dividing it out. It's a GCF. It's a greatest common factor, all right? In other words, y divides into y squared evenly. Y will divide into y no matter what y is. Okie doke. And what am I going to have left here? I'm going to have a 1. Now, 0 didn't change, did it? All of a sudden, things look pretty good. Because I'm going to take these two little pieces and I'm going to say, oh, how about it? Y equals, oh, that was quick, 0. And over here, I'm going to say y minus 1 equals 0. Because in other words, in order to get a 0, one of these factors has to equal to 0. So y equals 0, that's a piece of cake. Y minus 1 is going to be a piece of cake because guess what? It has to be 1. Y equals 1. So you said, I think I guessed that out. But in the way it was looking here, that would not be the quickest thing you'd probably go to and try to do. You have to simplify it down to something that you can recognize. And that's the whole thing with problem solving. If we have all this unknown that we're not sure what to do, we work with it until we get to something we are sure of how to work with, all right? And so you say, I don't think I've ever done factoring before. Well, if you have done factoring, this one comes out pretty nice all of a sudden. If you haven't, that's okay. We've got problems that won't involve factoring every day and such, but this was one of those that did. Now, second part says let's check. All right, so let's go back to y times y minus 4 plus 3 times y minus 4 equaling to negative 12. So our first goal, what happens when we put a 0 in here? Well, goodness, right there we put a 0. We put a 0. And we put a 0. Well, that's all wiped out, so that becomes 0. How about it? 0 minus 4, I'm counting negative 4. And I've got 3 times negative 4, which is going to give me negative 12. And my friends, get rid of that 0. We have a check, all right? That one looks good. So we just get rid of the 0 because it's when you add it to negative 12, you still keep negative 12. Now, what about our second option? How about it? Let's put a 1 in for y. 1 times 1 minus 4, I'm going to just go ahead and rewrite there. Plus 3 times 1 minus 4, does it give us negative 12? That's the big question. Well, first of all, let's talk about it. 1 minus 4, let's think about it. 1 minus 4, you're at 1 and you go to the left, 4 on the number line, you're in negative territory. It's going to be 1 times the negative 3, which is going to give us a negative 3. That looks good. Everybody good on that? Nod with me. This one, let's go ahead and play with it. 1 minus 4, oh, wait, it's still negative 3, isn't it? But this time we multiply it by 3. So that is going to give us negative 9. We multiply the 3 times that negative 3. Does it equal negative 12? Oh, yes, it does. Negative 12 equaling negative 12. Checks. So again, our two solutions, and both are good. Y equals 0 and y equals 1. Wow, you say that's a pretty good bit of work out there, Ernie. And sometimes they are. The checking part probably took a couple of minutes. And also, once you start thinking about it, how to get to the 0, things start working out beautifully here on the left-hand side. And before you know it, you're solved. Everything's good. So there you have it. Problem of the day, whew, that was. You had to think a little bit on that. That was not one of those you could just look at and say, oh, I got the answer. Takes a little bit of work, all right? And now, let's get a little bit of work going here. Let's give some calls, all right? 844-686-2378. Toll free, does not cost you anything to call and talk with me. Got a homework problem? We want to look at it. You maybe got some questions of just topics in general. How do you do certain ideas? We've had folks ask us things like that over the past 2 or 3 weeks. Give us a call, all right? That number again, 844-686-2378. This is our last day live this week, all right? Because so many of you are on this fall break time. And we're just looking to have a little fall break ourselves. How's that? Wouldn't that sound great? So we're going to be off tomorrow. We're going to give you a nice little specialized segments to come back for. Also Friday. And then Monday's Columbus Day, which we observe as a holiday here in many parts and many places. So we're going to also take that day off too. But we'll be back next Tuesday. But in the meantime, that means all your problems we need to solve today, right? So give us that call. 844-686-2378. We are looking forward to hearing from you as soon as possible, all right? That would be like, hey, maybe in the next 15, 20 minutes, all right? So give us some calls here. We've got operators waiting, and we will work the problems out live on there. And like I said, it doesn't cost you a cent. And, hey, have a good time doing it. Because, folks, you make the show rock when you call in. We really want to hear from you. We've had some good calls this week. We want to get a few more today before we take a little hiatus and come back next week going strong again. Now, that I went on and on, give us that call, 844-686-2378. 2378. We're looking forward to hearing from you. Let's take a look at another problem while we're waiting for some calls here. Let's see what we've got here. It says find the measure, and we're going to call these little angle X and angle Y. Well, you see where X and Y is there. What kind of triangle we got, everybody? It's a right triangle, isn't it? Now, let's talk about a little bit about this problem. And I see this is a great problem for an ACT or SAT type question, because some of you are saying, well, Ernie, it looks like there's a lot of stuff to do there. There really isn't. There really isn't to find those angle measures. And when you look at this problem, right off the bat, you see, oh, they're A's. What are we going to do with those variables? We're looking for a missing value, all right, of A that will unlock basically this little puzzle we've got here. We got a puzzle for you. We say that X plus Y and Z, well, it's in a right triangle. It's a triangle to begin with. And when everything adds up in a triangle, we get, you got it, 180 degrees. Now, what's the box about? The box, remember I said, it's a right triangle. So this we already know. We know angle Z is 90 degrees. What does that tell us? And some of you at home said, I know. And I love to watch you as you're reaching through the screen, but I can't quite tell. But you say you know. You know these two angles, it's possible they could be the same, but we're not really guaranteed that, nor are we told anything about this being isosceles. So we're going to assume it's probably not true, but we don't know. We really don't know. It could happen. But what we do know is that they add up to make 90 degrees. Why? Because these are acute angles. It's a right triangle. And if we've used up 90 degrees, that means we've got 90 left out of the 180 degrees we started with. By the way, another word for those two angles, they're complementary. Complementary angles are two angles that add up to 90 degrees. They're measures do. So our measures here, let's go ahead and play that game. We're going to say 3a plus 2 plus 2a plus 3 will give us 90 degrees. Now we're ready to unlock this puzzle. All right, everybody likes puzzles. I like puzzles. We all do. So let's see what happens. Okay, Marie, what's going to happen? We're going to put some like terms together. Remember, I keep talking about those things. You got 3 A's. I give you 2 more. You got 5 of them. Not 5a squareds, but just 5 A's. So we'll put a 5a down here. I see another 2 and a 3 that have no A's attached. So in other words, we took care of those. Now let's take care of these. And we've got 5a plus 5, and that's going to tally out to give us a big old 90 right there. And from here, it's pretty easy, isn't it? And by the way, while we're looking at easy, go ahead and give us that call. You've dying to do it, I know. 844-686-2378. Let's hear from you, all right? Now, speaking of that problem, let's take a look what's going on here. We got 2 5s we need to get rid of. One of them is connected by multiplication. This one is connected by addition. I need to really get rid of the first 5, which I'm pointing at right now, this little o plus. Hey, someone out there, I bet Ethan's already saying, Ernie, you know, you could divide 5 through everything and it's going to be a lot easier. And he's right. We could do it that way. But let's go ahead and finish it up since most of us probably already are putting the -5 to both sides. Let's play it that way. And then I'll come back and look at Ethan's way. Ethan's one of our Facebook faithful who likes using the greatest common factor approach to make things a lot simpler, which we just did in our problem of the day for those of you just now who have already been tuned in today. So we got 5a equaling to 85. Now, it's pretty simple. We're going to divide 5 into 85. I'll go to the calculator since some of you never believe I know what, I do know what I'm doing on this one. We should come up, I believe we're going to come up with 17. Let's see if that works. But remember, folks, that's not the answer yet. That's what A equals. All right, so we're back to A equals 17. There we go. But now the question is, what are those angles? What are those angles? Well, over here, let's play with them here. We got 3 times 17. We'll add 2. And the other one we've got up there at the top is 2 times 17. And we will add 3. And I'm going to kind of square that off. And we're going to see what we get. I'm seeing 3 times 17. My goodness, boom, boom, boom. That's 51. So we got 51 plus 2. How about 51, Ernie? There we go. Plus 2. That's 53. So there's our first situation. How about this little guy down here? I see 34 plus the 3, and I'm going to get 37. So at this point, I'm looking at these 2 degree values, and I've got to ask one more question. Do they add up to 90? That's how I know I did the right thing. That's how I know I got the right A. That's how I know I did the process correctly. These two do add up to 90 degrees. And that's good news for us. They are complementary. The A is the magic A. No other A is going to make that work. Okay, is everybody good on that? Now, I mentioned our friend Ethan. Ethan, I hope you don't mind me talking about you here, but it's a good idea. Ethan would have come up at 5A plus 5 equals 90, and he would say, I see greatest common factors that I can divide 3 by. There's a 5, and certainly we know 5 goes into 90 because there's 0 on the end. So let's divide 3 by 5, and we've got A plus 1. Well, that was easy, wasn't it? And now I think you all are going to see where it's going. Now, the biggest thing you got to think about, well, how many times will 5 go into 90? It's going to go 18 times. And at this point, what are we trying to solve for? We're trying to solve for A. Now, if we get the same 17 here, we know it's going to give us the same degree measure, so we aren't going to go back that far. But subtract the 1, get it over there, you've got A equaling to 17. So a lot of times, you know, again, it's tackling a problem 2 different ways. We can work it through, boom, 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 the way we learned in pre-algebra class and algebra 1 classes, bang, 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 and we get 17. And sometimes we get a little creative and start thinking, ooh, there's GCFs. And it's not necessarily anything you would learn in an Algebra 1 or an Algebra 2 class. It's just one of those things, a little bit of thing you notice about the numbers, and you say, hey, I think that'll work. Hey, you're right, it does. All right? So you get A equals 17, A equals 17 either way. So there we have it. And again, like I said, on Mathline, I like it when we can show some different approaches to solving the problem and getting the same answer. But I tell you what, our biggest thing I want y'all to just take care of right now is that 844-686-2378. Let's hear from you. We would love to. It's Wednesday afternoon. We want to play some math games with you guys live on the air, or in other words, let's work out some problems, all right? So in the meantime, I think we have a Hey Mathline that's waiting in the wings. So while we listen to Hey Mathline, you give us a call.
Hey Mathline, I am Vin from 8th grade in Florida. Could you give me an example to show that subtraction and division are not commutative operations?
Wow, Ben from Florida. Could you give an example to show that subtraction, wow, let me write a few notes down here, and division are not commutative? All right, so we're going to look at subtraction and division and see if they're not commutative operations. An example, we'll do one of each, all right, just for you, Ben. And by the way, it was one of those from one of our young folks who we got to have a Hey Mathline with up at Ripley's, the aquarium up in Gatlinburg. Once again, Ripley's, thank you for letting us come up there and do some shooting the past 2 summers. And it's been a lot of fun having those around here to look at. And I think he's from Florida, having a great time here, and appreciate these young folks being willing to have fun with us doing this. We'd love to do that, by the way, in your communities and in your schools also. All you guys do is let us know that your teacher's interested, and we will try to get a crew out and see what we can do with you, okay? Now, the idea is commutative. First of all, let's talk about commutative. What in the world is commutative? Some of you are saying, Ernie, that's a word. That's not math. Well, subtract's a word, division's a word, but they mean operations. Commutative has its own situation. Why didn't he mention addition and multiplication? Well, first of all, let's just look at it. If we said 3 plus 4, I just did 3 plus 3, well, it's not going to matter. That's not what I want. 3 plus 4 equals 4 plus 3. Well, I am really batting 0 today. I'll pull it down there, guys. Y'all can bring me back. There we go. You can tell. It's midweek. I was going to say it's a Monday, but it is not a Monday. Notice you get 3 plus 4, you get 7. 4 plus 3 gives you 7. This will mean the commutative property. You can shift things around. You can move. Commute means to move. And so many times we think it's commune. No, we're not singing Kumbaya or having fun with this. No, we are moving things around. So 3 plus 4 equals 4 plus 3. Addition, it doesn't matter what numbers I put in for these 2 spaces here. If I just reverse the order and keep a plus sign in between it, life is good. All right, we are not going to have a problem. The same thing goes if I decide I want to multiply. I want to do 3 times 4 and 4 times 3. Again, it doesn't matter what order they are. That's the commutative property. Basically, if we were using letters and variables as symbols, it would say that AB equals BA, all right? Or A plus B equals B plus A, depending on whether you're adding or whether you're multiplying. By the way, we get 12 and 12 here. Over here we got 7 and 7. So that's where it works, okay? The commutative property works there. Ben wanted an example to show, and all it takes is one example, a counterexample we call it, to show things are going to work or they don't work, all right? And let's see, in a counterexample, what we're looking for is that they don't work, all right? One example is all it takes. Now, I use just one here, but you could pick any numbers you wanted and you were still going to be able to get a true statement out of these two, because it's a property. It's a property for addition, a property for multiplication. But now let's look at subtraction. See what goes wrong here. Let's use 3 and 4. Why not? So I say 3 minus 4, and I'm going to say equals 4 minus 3. You say, well, Ernie, some people say that looks fine to them. But what's happening here? We're starting with 3 and taking away 4, which puts us in a negative territory. So we're going to have a negative 1 here. Now this side, 4 minus 3, just what we were doing in fourth grade. How about first grade? Maybe even kindergarten. Some of y'all were doing these things. Have 4 things, took away 3. You still have 1. All right, you're not in the hole. You don't owe anybody anything. But obviously, these numbers are not the same. You got it? Everybody's got that, right? So Ben, there's your example right there. And again, as long as you make the two numbers distinctly different, you're going to get that relationship. Now, if I had 3 and 3 like I was about to do over here, not very smart, was I? But if you put 3 minus 3 and 3 minus 3, of course, you're going to get 0 both times. You've got to have distinctly different numbers there to make that subtraction, make that argument for subtraction not being commutative, all right? Now, what about division? Well, let's say, oh, why not? Let's use something better here. How about 12 divided by 3 and 3 divided by 12, okay? So in other words, the question is, does it work? And this is one of the things, I'm going to just put a little thing in. Adults, parents, I know a lot of you watch this show. There is a difference between, this says 12 divided by 3. This says 3 divided by 12. There is a difference in that. Some of our students and young folks don't get it because they'll tell me something and I have to ask, what's inside, what's outside, so to speak. And they go like, oh, it works this way. So it does matter what we say first. So the question is, are they equal? That's what we're trying to say. I'm going to say no. Ben says they aren't, but he said, look, can we get a deal here? So over here I can say 12 divided by 3, that is going to give me 4. All right? Pretty straightforward. 3 divided by 12, that's like I'm saying put the 3 on the inside and divide 12 into that. Well, it won't go. It won't even go one time, all right? Actually, what it does come out to give us is 1/4. So definitely not equal, not equal. Now, some of you say, well, how did you figure out that 3 divided by 12 was 1/4, Ernie? Well, let's look at another option. Division. Remember, we talk about on the show almost every day. Not every day, but many days. We have 3 over 12. That's division. 12 divided by 3, that's division. It gives us 4. On the other side, 3 over 12, that's division. And that's what this is telling me, okay? So here I go. I've got 12 over 3, which, my friends, gives me, you got it, 4. On this side, divided by 3, it's going to give me 1/4, and there's my situation. So again, whether you represent it in this fashion, you're still creating fractions, so to speak. This one just happened to come out even. It was nice. This one, well, it came out sort of even. It would have come out, if we wanted to play decimals, it would have been 25/100, 0.25. But 3 over 12 comes out to 1/4, but they certainly are not the same. Think about that being $4, that's 25 cents. How about that? Definitely not the same. And sometimes we have people and our young folks and some of our adults out there many times think, oh, it's the same operation. It's the same deal. You're doing the same process. We are doing the process, but we're getting different results because who goes first? Who goes in the numerator? Who goes in the denominator? Very straightforward. Okay, well, so there you go, Ben. Don't know if you expected all that for your answer, but there is quite a rationale there, and I want people to see that that makes a difference because it's kind of one of those mistakes we do make, sometimes careless mistakes, as students and as adults. So anyway, hey folks, we are here. We're live on the air today. 844-686-2378 is our number. We're getting close to the end of the show. Should you still have a problem or question, we'll be glad to deal with you after the show today. or you can send in a Facebook to us. And speaking of Facebook, can we take a look at that real quick, guys? We like it. We love it. You want us. You like us. You love us. We love it. All that good stuff. But what we really want you to do is join our page and, excuse me, share us. I'm all choked up over Facebook today. www.facebook.com/Mathline online, where you can be a part of our community. Where you see our problems of the day posted in advance, and you can go scratch your head on something, and other times you're going like, I got this one. Put an answer down there and feel good about it, all right? So again, like us, love us, and definitely share us. Share us with your friends so we can get the word out about our show and our processes of problem solving. Again, we are not going to be here on Thursday or Friday this week. We will not be here Monday. Live, anyway. We'll be here with some specialized segments. You watch those, and we'll be back again next week to see you again soon.